things and record today's lesson with y'all. Okay. For the warm-up, this is a TSI prep warm-up. TSI is coming up. We've got to make sure that we're practicing TSI. And so when we do these warm-ups, don't just copy down the things that I write, like ask questions if you don't understand it. Last class we did the warm-ups where we had stuff that were squared, or the last time we did a warm-up, it was stuff that was squared. Now we have stuff that's square roots. And so neither one of those are things we're really good at. So we need to brush up those skills. So does anybody remember what the inverse? So inverses are add, subtract, their inverses, multiplied by their inverses, square, square root, those are inverses. And so does anybody remember what this inverse is of square rooting something? Squaring, yes, squaring. So if we want to undo stuff that's square rooted, we have to square this side and it will undo, and then we can square this side. So that undoes that square root. And so we're left with m plus 5 on this side equals 7 squared. 7 squared, what is that? 7 times 7. Seven times 7, 49. Good job. 49. And then this is just a simple one-step equation. What do I do to solve it? I want m by itself. Yeah, I want m by itself, so I need to subtract 5. 49 minus 5, what do we get? 44. Very good. Did anybody get that right? Hey, listen, that's okay. That's why we're doing these. So remember, you'll take off 10 points for that. That's fine. You're at a 90 right now. The next one, we're going to solve it. And for this one, we have to take care of addition and subtraction first. So we need to subtract 5. We've got 7 minus 5, 2. And so to get rid of that square root again, we have to square both sides. So that gets rid of the square root on this side. So I just have m. And then what's 2 times 2? 4. So if you didn't get either one of these right, it's not a big deal. Make sure that you fix them. You'll give yourself an 80 and you will go turn it in. And then you will pick up the worksheet for today. So an 80 is not a bad grade. Cool. So was that the theme was neon?
Yeah.
Does it change every week or whatever?
Next game is blackout. Everybody has to get black.
Okay, well, you got to remind me. I didn't even know yesterday was game day.
Next
So-
game is Friday.
Next week is Friday.
Yeah, next
It's
game.
a blackout day. So I got to get all my black.
Yeah, Huh? With Neon?
Black on black on black on black on black. Okay.
We'll wear white suits, black jeans.
You're gonna wear a black suit. Those what are they called? The like ones that like the blue man, like the ones that are the whole thing that have even your face covered. That's like the elastic suit.
Yeah. we'll do that.
I don't know because they're like leggings, I feel like.
They're like, yeah, it's like.
It's like that dry fit
yeah,
material.
yeah.
It's just tighter.
Yeah.
Yeah. That would be funny from yelling. Today's lesson is over fractions. Raise your hand if you love fractions. I didn't think so. Nobody really likes fractions. What we really like to do with fractions is just change them to a decimal so that we can use them. We cannot do that. We're not doing that anymore because TSI doesn't have it working like that. For all the things that we're doing today, I really don't think that you're going to need a calculator. So if at any time you feel like you want to get up and go get a calculator, you can, but I don't think that you have to have a calculator for today. But what you really don't need is your phone. So make sure that you flip your phone over, slide it over onto the other desk, put away that temptation, because today we gotta learn math. So on these fractions, what we're gonna do first is we're gonna review the stuff that we've already done this year. The stuff we've already done this year is adding and subtracting. And to be honest, that is more difficult than multiplying. I know it doesn't seem like it, but it is. The reason why it's more challenging is because you have to make sure with the denominators, what has to happen with the denominators? They have to be common. They have to be alike. So any of those things, they have to be the same. They have to be the same or alike, common. They have to be a common denominator. They have to be alike. They have to be the same. And so when you're adding and subtracting, you have to make sure of that first. Have to. So some of these are a little bit more challenging and some are not that bad. Which one is going to be the easiest one to do? Why? Yeah. Number 4 is the easiest one for us to do because you already have a like denominator. So you can go ahead and put those together. I'm going to do that one on the board. You do that one on your paper. Let's make sure we get the same thing. You don't have to do anything except for add straight across or subtract in this case. Amir, come on. You got this. Did y'all get the same thing? Yeah, that one was easy because the numbers were the same for the denominator. So that one wasn't so bad. However, not always do we have that luxury. So when we look at question number 1, the denominators aren't the same. And I can't really turn 2 into 5. So what denominator could I use though? I could use 10. Very good. Very, very good. You got here on time and you're on top of things. It's going to be a good Friday for you. Yeah. So for this one, we can only change the 2 or the 5. And a lot of times, if you don't ever want to think about it, you could just take those 2 numbers and multiply them together and it would tell you what you could make it. So 2 times 5 is 10. So you can always turn it into that. If you don't want to think about it, just turn it into whatever the product is of those. So that means that I'm going to have to do a little bit of extra work for this one. I'm going to have to multiply this one by 5 over 5, this one by 2 over 2. So I'm going to jot that down. And then I'm going to rewrite them both. Don't forget that that first one has to stay negative. And they're both going to have a denominator of 10 because that's my whole goal. 5 times 3 is 15. And then 8 times 2 is 16. Now that I have like denominators, my answer is going to have that same denominator. And then I can look at the numerators. I have negative 15 plus 16, or you could also think of it as 16 minus 15. Say that again. It's 1. And I can't reduce that, so it is just that.
No.
Say that again.
Is it 5 over 5?
Yes, I'm sorry. Yes. Yes. I was multiplying that fraction to get a common denominator. For 2, question number 2, this one, I can just multiply the 2 to get 4. So what would I multiply this fraction by? 2 over 2, yep. I also see something else that with this one, I have minus, minus, so I could go ahead and change that to a plus as I rewrite it. And now that my denominators are the same, it's going to be the same in the answer. And then I just add across the top. So 7 plus 2 gives me 9. Does 9 over 4 reduce? Nope. So it just is what it is, and I'm going to leave it as a fraction. We only have one last one in this section. I'm going to do it up on the board. I really want you to try to do it on your own paper. This is one that you're going to have to change both denominators because you can't turn 4 into 5. You can't turn 5 into 4. So it's going to be more like this problem. But I'm going to do it up on the board. Just try it yourself. See if you can do it. Did y'all get the same thing? Okay. Any of you that struggled with it, what did you do wrong? You don't know? What did you start with doing?
No, I just wrote it like, no, I think what I did was like 10 about like a little bit of what I knew.
Oh, you were changing the denominators into 10, kind of looking at the question number 1 as an example. To kind of follow, yes.
You get 31 for 3.
So 35 minus 4 on the top. So 35, 34, 33, 32, 31. So that's how I got 31 on the top.
Oh, fraction 2 is 35. Okay.
Yes.
I'm done.
Anybody else that made a mistake? What did you do wrong? No, I don't think you are because I heard somebody else look up and go, oh, what did you do wrong?
I put 8 out of 10 because you said to multiply the bottom, but you couldn't know what it was. So I just did that. I don't know. I just put 8 on top. Put 7.
Okay. So when you looked up and you saw what I did it make sense?
No.
No? Do you still not have any idea what I did? Okay,
I don't
well
know
then
what
what?
you did.
Then I need to go over it with you. So I have to make those bottom denominators the same. And I have a 5 and I have a 4. And I can't turn one into the other. Like a lot of times that's easy and a lot of times that works. And that's your go-to. Just turn one into the other. But when you have a case like this where they can't change into each other, then you have to think of something that you could multiply them both by so that you could make them the same. And one, I guess, tip or trick is just take those two numbers and multiply them by themselves, and it'll tell you what that new denominator should be. So if I have 5 and 4, 5 times 4 is 20. That's what I want to make the denominator, because both 5 and 4 can be turned into 20. And so on number 1, that's what I did. 2 can't turn into 5. And so I just made it easy, and I did 2 times 5 is 10. That's my new denominator.
Okay, that makes sense.
So if you can't turn one into the other, your new denominator, if you don't want to think about it, just multiply whatever those numbers are together. That's going to be your new denominator. And if you do that, it's pretty easy to know what you multiply each side by, because it's going to be the denominator of the other one. So here, I said my new denominator is going to be 10, and it's 2 times 5. So then this one you multiply by the other denominator, 5 over 5. And then this one you multiply by the other denominator, 2 over 2. That's the same thing I did down here. I wanted it to be 20, and it's multiplying these together. So this side you multiply by that denominator, and then for this side you multiply by that denominator.
Okay.
Does that make sense?
That's why I was confused.
Okay. Yeah, and that's a struggle for us. Like, listen, we learned fractions in like 5th or 6th grade, and then we haven't done them. And so we've just been pretending how to do them since then. And glad when it was a multiple choice and maybe we guessed right. Right? We never really knew how to do fractions. So we have to learn how to do fractions. Now what we're going to do is new stuff, or new to some of y'all. We're going, did you say great? Well, you're actually going to like this. I think multiplying is easier. Adding is a struggle because we have to find those like denominators. There's that extra step because you cannot put them together unless that is true.
I was gonna say that too, that's why I was confused.
These are a struggle. They are. Adding fractions is tough. Multiplying fractions is easier because it doesn't matter what the denominator is. They can be the same, they can be different. It does not matter. You do not have to check that. It does not matter. And so when we multiply fractions, we multiply straight across. So we multiply straight across, and the denominators, they don't matter. I mean, yes, we multiply them. You don't ignore them. But what they are doesn't matter. And so this is the hint. You can multiply these straight across, and sometimes you're going to need a calculator because the numbers are going to be big. If you take a look, we've got some really big numbers down here, 15 times 11 or 22 times, like some of them are big. But I told you that I don't think you're going to need a calculator because I really don't think you do if you do this hint first. So the hint says, always check to simplify or reduce first. If you simplify or reduce, then it will make multiplying fractions way easier. Then it becomes numbers you can do in your head. What do I mean by that? All right. When I take a look at question number 1, and again, the denominators don't matter. I'm going to multiply straight across, the top times top, bottom times bottom. But if I reduce it first, if I can, then it will help me. And so what I can look at first is I can look at, does this reduce? Well, it doesn't. Does this reduce? It doesn't. And then I can look diagonally, because if we're multiplying together, you can diagonally reduce. So then I can look 3 over 11. Does that reduce? No. What about 8 over 2? Yeah. And so I always look at the smaller number dividing into the bigger number. So for this one, yeah, 8 divided by 2, what is that? It's 4. So what's going to happen is that the bottom, the denominator, that turns into a 1, and then the top turns into a 4. And now when I multiply straight across, it's a negative times a positive, so the answer will be negative. And then when I look across the top, I have 3 times 4. That's something we can do in our head. That's 12. And the bottom, I have 1 times 11. And then if you do that, you usually don't ever have to simplify in the end because it's already simplified. That's it. That's it. The next one, first thing that I notice is that it's a negative times a negative. We could change that to a positive. So I know my answer is going to be positive. And then I can do the same thing. I can look in each fraction that can't be reduced and neither can that, but now diagonally, 7 and 14. Uh-huh. So I know that 7 goes into 14 2 times, right? Okay, so this time we need to make sure that the bigger number goes with the bigger number. So 7 goes into 14 2 times. So the 2, I'm reducing these, the 2 has to go down here. And this becomes a 1 up here. And so now when I multiply across, I have 1 times 1, and that's just 1. And in the denominator, I have 4 times 2. The next one, I'm going to do the same thing. I'm going to take a look. Neither one of these reduce independently, but that doesn't reduce. 4 and 20, yeah. 4 goes into 20 how many times? 5. So that will become a 1 and this becomes a 5. When I multiply across, I have 5 times 5 on the top, 25, and 1 times 3 on the bottom, or just 3. We can do this. We can do this. I'm going to do one more with you, and then I'm going to let you try and do the rest. So let's take a look at number 4. So for number 4, first thing that I notice is a negative times a positive, and I don't want to forget that. So my answer is definitely going to be a negative. Then I don't have to worry about it. And then as I look through, 7 doesn't go into 15. Nope. 2 will go into 4. That definitely will help me. So if I reduce this, the 2 becomes a 1, and then the 4 becomes a 2. So now multiplying straight across, 15 times 1 is 15, and then 2 times 7 is 14. Y'all feeling good about this? Good. So I'm going to give you guys like a few minutes. I want you to go through and I want you to try these. Let's give us a timer. How about 5 minutes? Yes, sir. Yep. It's on the back wall. Yeah, so another thing you can do is just multiply straight across and then simplify at the end. That works too. Okay. One thing that you can do if doing that is a struggle for you, just multiply straight across. So 2 times 4. And then 5 times 10 is 15. Can that reduce? So I know you can just start by halving.
I think, yeah, 1 at the top of 2. And then 5 at the bottom. And then. No, it's not.
Yes, sir. You should.
because one times. I mean, no, that's what I was saying, but one just can't. That's what I meant to say, shut up, shut up.
If
That's what I was
multiplying straight, if reducing first is, confusing you, you don't have to. You can just multiply straight across and then reduce at the end. That works too.
I'm trying to follow this. Okay, what's your answer then? What did you get? Now you look at I got.
Alrighty.
Okay, so when he did was on the right, at the end, like.
Remember over here, we wanted to get.
Oh, wait.
You are on the right track.
Okay, that's good.
No.
So wait,
You just switched
But
the
you
number.
wouldn't, but.
You switched the numbers.
See, that's what I was trying to say, but y'all wouldn't let me get there.
No, you said it wrong.
Okay, because I was trying to explain and I got tongue twisted. That's what happened when I was put on the spot.
it's four.
Shut up.
It's like.
See, that's, no, listen, that's what I was trying to get at, but I was confusing myself.
I was doing.
You did?
Amir,
Twice.
I'm not allowed to. I'm not allowed to. Because if a shooter came up in here, we wouldn't want him to get in the door.
That's not it. Oh, wait, that is it. You were right. We're going.
I was trying to count and use my head, but.
So it will be two, right? Two and one.
Oh, yeah.
Oh, wait, what do you mean?
No, I think it's up to, because we already put 8 into it.
One thing I also want to point out is that if you don't really like reducing, you don't have to reduce first. It just makes it a little bit easier. But some of y'all might not think so. So if you don't think so, one thing that you can do is just multiply straight across. So if you look at question number 5, if you just multiply straight across, 2 times 4 is 8. And 5 times 10 is 50. The only difference is now at the end, I need to reduce. So it doesn't really matter if you reduce first or if you reduce at the end, you can get the right answer. So if I reduce this, I know that they're both even numbers, so I can divide them both by 2. 8 divided by 2 is 4. 50 divided by 2 is 25, and that doesn't reduce anymore, so that is my answer. So it doesn't really matter if you want to just multiply the top, multiply the bottom, or if you want to simplify and then multiply. Either one you can do. Either one is okay. All right, we have finished our first page. So we're gonna take a moment. We're gonna do some eye yoga, take a deep breath or two. This can give some of you a chance to kind of finish up that section, and then we're gonna move on to the back. So let's do some eye calisthenics, get our eyes going.
Oh. It's smaller than 15. And then what we already did was
So what we're gonna do is we're gonna flip over the page and we're gonna go to the back now. So we're gonna go to the back. And if you didn't finish one or two of those on the front, that's fine, because we're gonna have time at the end, you can get back to it. So even if you didn't do your eye yoga, you can still take a deep breath with me. Ty, did you do your eye yoga? On the back. So what we just did on the front at the bottom where we were multiplying fractions and we were multiplying them straight across, we're going to do the same thing, but what's different? Look at these problems. What's different? There's letters. What do we call letters in math? Call them what? Yeah, they're evil. What do we call them? Starts with a V.
Variables.
Variables.
Oh, it's right there.
Variables. Yes, they're variables. So it's a little bit different. We're adding on that extra layer here, but we can do the same things. So still, if you prefer a method of just multiplying straight across and then reducing at the end, that's fine. If you want to reduce them as you go, that's also fine. And so I'll try and do a few both ways. What is our hint? It's the same hint on the front. Always check to simplify. Again, unless you feel like you like the method of just multiplying straight across, that works too. Then you have to simplify at the end. So when we take a look at question number 10, we're going to look for the same things first. So it's a positive times a positive. Our answer will be positive. So we're good there. And 10 over 9, that doesn't reduce. 16 over 13, that doesn't reduce. Now let's look diagonally. 10 and 13, does that reduce? No. What about 9 and 16? No. So this is actually one that you can't reduce first. We just have to multiply across. This is actually, I meant to make the 16 and 18. Oops, I didn't. But that's okay. We can do this one. So because I made you guys not get a calculator, you might need your phone calculator for just this one because most of the other ones do reduce first. So for this one, you might not know what 10 times 16 is. Oh, hold on. We have something extra here. We have ends. So the way that the variables work, you have to, if you have one that matches on the top and on the bottom, you have the same thing on the top and the bottom. So let's think about a number first. 5 over 5. What is that? Say it louder. 1. So what about 12 over 12? Well, then what's n over n? 1. Anything over itself is 1. It is 1. So it doesn't matter if it's W over W. It's still 1. So anytime we can find a letter on the top with the exact same letter on the bottom, they will cancel. But here's what we have to take note of. On this one, we have 1 in on the top, but we have 2 on the bottom. So I have 1 on the top and I have 2 on the bottom. I at least have 1 that's going to match up, right? So these are going to go away. I'm not going to put that finger down. I'll go the other direction. We'll just have 1 on the bottom. Okay, so those are going to reduce, and I'll show you what I mean. So these will actually reduce, and one of those will go away. So I'm just left with on the top, it's just going to be a 10 by itself. And then on the bottom, it's going to be a 13n. just one n, because one of those n's canceled out. And now if we multiply straight across, which again, this is the only one that you might have to use a calculator for, 10 times 16. You can always do 1 times 16, which is 16, and then add however many zeros are when you're multiplying by 10, 100, 1,000. And then on the bottom, we have 9 times 13. I don't know what that is in my head. You're gonna have to type that in a calculator. $117, and there's an n there, so we just put an n. And it couldn't reduce at the beginning, so it can't reduce at the end. So even though we're adding on the variables, don't stress, you can do this. Question number 11. It's a positive times a, you know what? I made all of these positive times a positive, so you don't have to worry about the negatives. So for this one, we can look across and diagonally. So 16 and 8, does that reduce? Yeah. So 8 can go into 16 2 times. So the number part, that can reduce. Oh, and there's an X and an X. There's one X on the top, so one X on the bottom. Those will also reduce. Those go away. So I have 1 down here, and this just becomes 2. And then the other way, 17 and 6, those don't reduce, but that's okay. I can multiply across now. 2 times 6 is 12. 17 times 1 is 17. The next one, 8 and 7 don't reduce. There's only one thing with X's, so that can't reduce. 2 and 18, yeah, that can reduce. So 2 goes into 18 how many times? 9, close, close, close. And if we multiply straight across the top, it's just 1 times 8x squared. So we'll leave it 8x squared. And then on the bottom, we've got 7 times 9. If you don't know what that is, use your fingers. Do the nines trick on your fingers. Do you know a nines trick? Okay, so if you, anytime you multiply by 9, you can hold your hands out. You have to hold them out like this. And then you count, you have to count from your left. You count down however many fingers it is. So it's 9 times 7. So 1, 2, 3, 4, 5, 6, 7. And then it's this side, which is 563 is your answer. You didn't know that? Yeah, so it works for anything, especially if you struggle with nines. So like 9 times 5, well, this is the 5th finger, so I put it down, it's 45. Mind blown. I just saw it. I saw it sparking. Yeah, so 7 times 9 is 63. Yeah, it's a nice trick. It's a nines trick. So I'm going to let you guys try the last 3. I know that these are brand new to us, but we're going to try them. I'll give you another 5 minutes. And it's okay, talk to each other.
All right, 7 going to 11.
But and I'm done.
Wait. That's 12 going to 14.
Okay, we're finishing the last 3 in this section.
Oh, wait. You're multiplying across, like on a 14.
Mhm.
So it's 7
I think we can write down here.
squared.
X squared, yep.
And
Because if it's going into 12, then what's left?
So how many X's are you gonna have on the top now?
Do they cancel out each other? On
That's
top?
not very bad.
No, you multiply across. You can't cancel out on the same row.
Okay.
Yeah. one at the bottom and three
So
at
it
the
means that you got 3 on the top now. Yeah, so if you have 2 over here and 1 over here, when you multiply it, it means you have 3 total.
bottom.
When you multiply with exponents, you add them.
You have to understand. This was, oh, I forgot about the. Yeah, I forgot about the. I'm sorry. Yeah, that's what I was thinking. Yeah.
Go ahead. What you about to say? Go ahead.
30.
I just can't. What's that? I don't know. At the bottom? 77?
So that is 3.
This way is one. That looks about right.
Is this right?
See, that's how, so why didn't you know?
You could reduce this one, make it a little easier for yourself.
How did we get that backwards?
Oh, you multiply across the top. So if you reduce this to 1/3, then multiplying across the top, 3 times 11 is 33, and you still have a W, and across the bottom, 7 times 1 is
Oh, we
7.
did it the wrong.
Okay, so why didn't you know? If you knew better.
It was right. You just have to do it.
I told you. Look, I told you. I knew it was either wrong or right. And it was a chance. Oh. So what's the answer you got here? No, wait. No. What's the answer you just got? Go ahead, show them.
You guys see what it says.
Okay. But that's not what you said.
Oh, you're just like this, the whole year.
I think I wrote it the same way. Maybe we could get past it. It's not, we have 2 seconds left.
Yeah, you still got some time.
Okay. If you let me finish.
You let me do it.
No, I'm saying, y'all don't really let me talk. I'm, no, because I be trying to say stuff and my words don't come out.
You never even say anything.
Okay, because I'm done, all right, 10 seconds left. We have nothing to show for it. Well, one question. And I tried to help.
Y'all got that.
What about you? Yeah, no, I'm 3 done. No, I did one more, so I think that's-
You can do it alone.
How did you do it? We did it together. How
I
did you
did
do
it by myself.
With what? app?
Me, myself, and I. It's like,
Besides, yeah, besides the calculator and your brain.
yeah. Yeah, very good.
So smart. So serious. Let's give it up. for y'all.
I heard it. I heard it too. So we just have one section left before we are done today. We are definitely almost done today. But first, I need you guys to stand up. I really need to know where my people are. You like this part?
Yes.
Okay.
See, look, somebody's trying to prank us.
Oh, yeah, they did.
It's a prank, right? That right?
That's gonna be got locked out.
They running. That's crazy.
Well, they really got Amir because they got him to go outside and get locked out.
Oh, but how did they get away so fast?
So I need to know where my people are. So on the left, over here, here's my Chick-fil-A people on the left, and Whataburger on the right. So I need
That's
to
a
know
little too expensive.
what's too expensive? Chick-fil-A?
Yeah.
Well, you're on the Chick-fil-A side.
They're
so
both
this is
expensive,
Chick-fil-A, this is Whataburger.
But Chick-fil-A be a different.
Whataburger.
This made me want to chicken.
Whataburger ain't like this one. Food work.
So all y'all are team Whataburger? Yeah? Is somebody still knocking?
I think so.
You guys are Chick-fil-A?
Chick-fil-A, all the way.
I don't think I could choose because for me, it's like favorites are hard. Like my favorite color is rainbow. It's hard for me to choose. If we're doing breakfast or lunch or dinner, it's gonna change. Breakfast.
Breakfast.
Yeah, I feel like
Breakfast. Like I can change my answer. Also, like, are we talking about a burger? Because
Just 'cause, like-
Chick-fil-A doesn't even have a burger. Are we talking about?
Those are small.
Chicken
Yeah, Chick-fil-A don't
sandwich,
fill me up.
chicken
Yeah,
sandwich?
exactly. They never fill me up.
Okay.
I was just about to
They
say.
never fills me up.
what?
It never-
Okay. Well, I just needed to know who my people are.
That's why.
I could go either way. I could go either way, easy.
No, I'm just saying.
My kids never get a full French fry from either place. I get into them. Like,
Their fries, don't get me started on their
once
fries.
they get their little kids meal, like they only get half a kids meal fry because mommy maybe ate some of their fries. I eat some of those fries. Fries are good. Fries are good. Fries are good. All right, well, we can sit down. We've only got one more section left and we're gonna be done for today. The last section is solving equations, and sometimes there's either fractions in your answer or there's fractions in the problem. But we kind of got to remember solving equations. So pretty much every day, I try and add a little bit of solving in there because we still struggle with solving. So we're going to go through here. And I'm going to put something up on the board. Do y'all remember PEMDAS?
Yes.
Okay, well, with PEMDAS, we're kind of doing it a little bit backwards when we solve equations. So when we solve equations, we do P's, MD. When you solve equations, you have to do P's, MD. So you kind of have to switch the addition, subtraction, and the multiplication, division when you are solving. Okay, when you are solving equations, you've got to switch those two operations because when we're solving, we're undoing operations. So for this first one, if my goal is to get X by itself, then I need to get rid of the 4 and I need to get rid of the 2. Well, reverse PEMDAS or P's MD tells me I have to do addition, subtraction first. So first I have to get rid of the +2. And here's the thing. Anytime you see fractions in the solving problems, they're actually easier. Because fraction means divide. What's the inverse of divide? Multiply. Y'all are better at multiplying than dividing. So anytime you see a fraction, it's actually easier because it just means multiply. So for this one, I have to first get rid of the subtract. So 6 minus 2, we get 4. And then last, all I gotta do is get rid of the divide by 4. So the inverse of divide by 4 is multiply by 4. So I'm gonna take the 4 over and I will multiply by 4. What's 4 times 4? 16. Done. That's it.
What?
My other teachers put me all through hell.
That's it. Let's go ahead and go straight down. Let's do 19 because it kind of looks the same. This one looks the same where there's a fraction. So let's do this one. So P's MD tells me that I got to do the addition subtraction first. So I got to take the 4 over. So if it's a +4 or a +4, I have to subtract 4. It doesn't matter if we start with a 0. Don't stress about that. So what is 0 minus 4? -4. Again, we have a fraction in the problem, but fraction in the problem is not a big deal. All it means is I'm going to have to multiply to undo it. So if I take the 5 over and I multiply by 5, 5 times -4 is going to be a negative. 5 times 4 is -20. We can keep going straight down. There's another part that I like to add to the P's MD, and that's CLT. And that just means combine like terms. Sometimes you need to, sometimes you don't. If we go straight down to question number 22, you see how you have two things with an N? We have to combine like terms. So that's the only thing with this one is we got to combine like terms first. So if I have 2 and then I add 1 more, how many do I have? I have 3. If I have 2 and I add 1 more, I have 2 N's and then I add 1 more in. So I have 3 N. And then to get N all by itself, I'm multiplying by 3. So I need to come over here and divide by 3. Does 13 divided by 3, does that work out? It's going to give us a decimal. We don't want decimals. So we just get N is equal to -13/3. And that is your answer. So this whole section, for most of them, I think there might be the exception of one, that you either have fraction in the problem or you might have fraction in the answer. We just need to get used to having fractions. There's nothing wrong with having fractions. So we're going to continue working on this section. And so you're just solving the equation. You need to do addition, subtraction first, and then multiplication, division, last. That's it. That's it. We got 25 minutes almost. So all we're doing is finishing this worksheet. About 20 minutes to finish this worksheet. Did that spill on her?
I have my phone, right?